Start recording. No questions? All right, then we are going to carry on from where we left off last day. Yeah, all right. So, la 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 la, la 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 la, here we go. Okay, so last day we had looked at an equilibrium system where we mixed HIN minus, HIN1 with IN minus, and HA1 with HIN. And we came up with the fact that we have an equilibrium system with the two, the acid and the base of the acid and the base. I have a pen here. Where's my pen? The acid and the base of one species are going to be on opposite sides, and the acid and the base of the other species are also going to be on opposite sides. So the conjugate acid-base pairs are across from one another. And do you remember which side is always favored? Is it the stronger side or the weaker side? The weaker side is always favored. Okay. So we have determined, and we're actually going to skip over this little bit at the bottom of page 15, because it's just another way of looking at how to determine what color each of the species is. Or maybe we shouldn't. Maybe we should do it. Sure. Okay. Do you remember last day we discovered that HIN1 was red and IN minus was yellow? Remember that? Yes? There's another way to look at it. Yesterday, the way we looked at it is we said, if we add hydrogen, that shifts it towards the hydrogen form. Yes, the acid form. If we add hydroxide, that shifts it towards the base form. So if we add strong acid, it shifts the indicator towards the acid form. If we add strong base, it shifts it towards the base form of the indicator. Do we remember that? If you add a strong base acid, you'll see the acid form of the indicator. If you add a strong base, you'll see the base form of the indicator. Another way to look at that is to say we have some HCl What color do I want? Nothing here is blue, so that's okay. We have some HCl, and we have IN1 and IN1 minus. So HCl is an acid. What do acids react with? They react with bases. So this acid must react with the base form of the indicator. And what is the base form of the indicator? IN1 minus. So we're going to put our acid, and this is on page 15. Page 15. Sorry about that. I should have said that earlier. So we're going to take our acid, HCl, and we're going to react it with the base form of the indicator, IN minus. And when we do that, because this acid is, what kind of an acid is that? That is Strong. And because it is strong, what kind of an arrow do we have? We have a one-way arrow. And we will get the transfer of a hydrogen from the HCl onto the IN minus. Okay. And we're given some information here. We are told that when we put HCl together with HIN minus, it turns red. Yes? When we put HCl together with HIN minus, it turns red. That's from our data table. So far, so good? I need more people to nod. If you get it, it's yeah? Okay, all right. So it turns red. And if this is a one-way arrow, that means that the species over here has to be red. So the only species present in that well at the end of that reaction are the products. So we are looking at Cl minus and HIN1, and HIN1 therefore must be red. So you can also figure it out this way, which one is red and which one is, what was the other color? Yellow, I think. It doesn't matter which way you choose to figure it out, whatever makes the most sense to you, the way we did it yesterday or the way we're doing it today. If we put NaOH with the indicator, the solution turns yellow. NaOH is a base, therefore it must react with what form of the indicator? The acid or the base? The acid form of HIN1, which is HIN1. So we're going to take our base, NaOH, which is strong, and react it with the acid, HIN1. And because it is strong, what kind of arrow is that going to be in that reaction? A one-way arrow. And because when we put these things together, the only thing left is going to be Na plus and In minus. So when we write NaIn, that is actually Na plus and In minus. If we want to write that as a net ionic equation, we can get rid of the spectator ion. Na plus is a spectator. Okay, so we can just write it as In minus and water. But regardless, what we have at the end in our little well on the spot plate is Na plus, In minus, and, well, water. And I'm not even going to include water because water is a solvent. Yeah? I mean, you could. So the Na plus is colorless. The solvent is water. This thing turned yellow. What does that tell us? Who is yellow? The indicator. That's not enough. The indicator is HIN1 and IN1 minus. IN1 minus. That is our yellow thing, okay? Now that we know that, we can go into looking here and saying, and this is where, let's see, no, we're okay. I'm going to make this red. I'm going to make this yellow. And if we have HIN1 and HA1, so if we're looking at this one here and this one here, if we're looking at those two together, we have got red. Yes? So if we put all of our species, we've got HA1, we got, whoops, we got HA1, we got A1 minus, we got HIN1, we got IN1 minus. When we put those into the spot plate, who goes on what side of the equilibrium? We just did this. So I'm not asking you anything new. Tell your partner. Who goes on what side? If we assume HA1 is over here, who else goes? Who goes on the right? There's got to be one of them that goes on the right, at least one of them. A1 minus, A1 minus. And if that's the case, where does HIN1 go? Right beside who? The A1 minus. So we got HIN1, and over here, that means we're left with IN1 minus. Once you have that set up, you can label your things as red and yellow because you have that information from before, right? We know that IN1 minus is yellow, and we know that HIN is red. So, what do we see when we mix these two together? When we mix these guys together, we see, read the table. Tell your partner, what do we see when we mix them together? What color? Is it red or yellow that we see when we mix HIN1 with HA1? What do we see? We see red. Yes, I'm seeing red. Okay, that was just silly of me. We see red. Okay, there it is right there. If we see red, which side is favored? Products are favored. And if the products are favored, then who is the stronger acid, HA1 or HIN1? HA1 is the stronger acid. HIN1 is the weaker acid because the weaker side is always favored. Okay, so HA, whoops, that should be a big A. Now, all these little blanks down here are just to say you could have written this equilibrium as HA1 plus IN1 minus in equilibrium with A1 minus and HIN1. Would it have been okay to write it as HIN1 plus A1 minus in equilibrium with HA1 plus IN1 minus? Would that be okay? Yeah, you can write it whichever way you want to. I have personally just chosen this one because that's what I randomly picked, okay? And it also resembles what we just did with HCl, yeah? When we put HCl with IN1 minus, you got Cl minus and HIN1. I shouldn't highlight this all in yellow because some of this is yellow and some of it is red. And we know that IN1 minus is yellow, and we know that HIN is red. And we know when we have a strong acid, we see the acid form. And this is our weaker acid. So even when this acid is not a strong acid, if it is the stronger acid, we will see the acid form of the indicator. So when the acid you mix it with is stronger than the indicator, you will see the acid form of the indicator. Does that make sense? Strong acid is always going to be stronger than the indicator. So if you have a stronger acid, it's going to show the same result as HCl. So an acid that is stronger than the indicator will always show the same result as a strong acid, HCl. I'm using so many words here. It irritates me, but there we are. Okay, so if you have an acid, HA, that is stronger than HIN, you're always going to get the same result as HCl. HCl is a strong acid. So you are going to see the color of HIN, not IN minus, and that's what you're going to see. Okay, so you're going to see the color of HIN. Anytime you have a strong acid or a stronger acid, you're going to see the color of HIN. So anytime an acid does the same as HCl, you know it is stronger than the indicator. Do I need to write that down as well? I'll let you finish writing that and then you can decide. I'll say it again when you're done. Once you've got it written down, see if you can explain to your partner how you can tell if an acid, HA, is stronger than the indicator acid. This is the question. I don't hear much talk. You should be talking. If you're not beside someone, maybe we'll find someone to be beside. Chloe, you want to come and sit beside Coco? So you've got somebody to chat with. Sanda, you want to come and sit beside Taran? So you have someone to chat with. Chloe, you can move a little closer to Eric, so you have someone to chat with. Bella, you and Maya could chat with each other. Zoe, you could turn around and chat with the two behind you. See if you can answer this question here. How can you tell if HA is stronger than HIND? If Nathan's asleep, you and he could change seats and you could talk with Nicole. You already talked about it. Okay, good. Nicole, did you get a chance to talk about it? Did you get a chance to talk about it? Yeah? Okay. What are you doing on your phone? Put that away. Okay, now that you've had a chat about that, have we finished our chat or do we need more time? Okay, we finished our chat. Would anyone like to volunteer to say what they've chatted about?
If the HA1 is the same on the same side as the HCl, then no.
If it's on the same side as the HCl? Not if it's on the same side, because I could have something that's weaker and then I would just see the yellow color. Yeah? If HA1 were weaker, we would see yellow. Yeah? So not if it's on the same side.
On the same. Because the HA1 is like placing the HCl is placing the HA1 in the second.
Yeah, in the second one, the HCl is replacing the HA1. And in both of these cases, HA1 was stronger, and we saw red. What would we see if HA1 were weaker? We would see yellow. So if HA1 turns it red, like it does here, we know that HA1 is stronger than HIN1, correct? So I could actually put like a little greater than sign here, because I could say this is greater than what we would follow to like up here. Does that make sense? Writing it like that? Does it make sense if I write that greater than sign that way? That means that this stuff here is greater than this stuff up here. Does that make sense? Yes? Okay. So if I needed to write the same thing, if I wanted to do HA2, is HA2 stronger than HIN1 or weaker than HIN1?
Weaker.
It's weaker. Yeah. How do you know it's weaker? Because it's yellow. Who else turned the indicator yellow? HA3 and NaOH. Can we all agree that NaOH is a weaker acid than any other acid? Because it's not an acid, it's a base. Okay, NaOH is a weaker acid than any other acid. Because it's a base. So if an HA does the same as HCl, where do I have room to write this? I don't. Down at the bottom. If an HA results in the same color, how about gives the same color? As HCl, it doesn't mean it's as strong as HCl. It means it is HCl is stronger than the indicator, so HA is also stronger than the indicator, right? Because we know that HCl is stronger than HIN. So if HA does the same as HCl, it will show the same color. Yeah? Okay. I feel like I'm just saying the same thing over and over again. Is it making sense? Yeah? Okay. Now, if one of the HAs, whichever one it is, if HA gives the same color as NaOH, then what can you say about the strength of HA compared with HIN? Is HA stronger or weaker than HIN? It's weaker. Yes? How do we feel about that? I got a thumbs up. Who else has got a thumbs up on that one? Excellent. Okay. Am I going too slowly? No? Okay. Okay. I think this is just basically saying what we already said. Do we want to go through this again? Because it just says what we already said. Is that a yes or a no? Never mind. Okay. So what we're going to do is we're just going to go down to the table here. Well, let's fill it in. In a Bronsted-Lowry acid-base equilibrium, the side with the weaker acid is always favored. The stronger acid is better at giving away its protons, so it spends more time in its weaker conjugate base form. All right. Now we go down here and we say HCl turned the indicator red. HCl is stronger than the indicator. That means HA1 is also stronger than the indicator. NaOH turns it yellow. NaOH is it a stronger or weaker acid than the indicator? It is a weaker acid. So anything that does the same as NaOH is also going to be weaker. So far, so good? Weaker, weaker. Maybe I should make those different colors so you can see it better. There we go. Could you figure out those arrows for HIN2? First of all, figure out whether HIN2, figure out the colors for each of the two species. I know you did it yesterday, but see if you can do it fresh today. What color is HIN2?
Yellow.
HIN2 is yellow. And that means that IN2 minus is what color is IN2 minus? Red? Take a look at your IN2 minus column. Look at that whole middle column. It is blue. See if you can put in your greater than and less than signs in that second column. Okay, and did you get the same results as I did? Excellent. Try HIN3. See if you can say what color is HIN3 and what color is IN3 minus. HIN3 is what color? Red. Excellent. And IN3 minus is blue. I'm going to go around the classroom and just point at you, and you're going to tell me greater than or less than as we go down the column. Maya, the first one. Sorry? Greater than or less than? HCl is stronger or weaker than HIN? Is HCl stronger or weaker than HIN3? Greater than. Yes, very good. Okay. Is NaOH stronger or weaker than HIN3, Matthew? Less than. Is HA1 stronger than, greater than, or less than HIN3, Owen? Greater than. Next, Owen. Is HA2
Greater than.
greater than? And James, HA3?
Greater than.
Greater than. Okay. And I'm going to just put these in green, and maybe I'll put those other ones in purple, just so we can see very easily color-coded what we've got. So looking at the color coding, can you tell me which of HA1, and you're reading from left to right, so taking a look at the data for HA1, so you're looking at this one, and this one, and this one, and then you're going to look at HA2, you're going to look at this one, and this one, and this one, and then you're going to look at HA3, this one, this one, this one. Which of the HA1s is stronger than the others? Which HA1 is stronger than the other HA?
HA1.
HA1 is the strongest of the three HAs. How do you know that? HA1 is the strongest of all of them because it's stronger than all three indicators, whereas HA2 is only stronger than two indicators, and HA3 is stronger than only one indicator. So that means in terms of strength, I wish I actually need to redo this so that it's not like 1, 2, 3, like strongest to weakest, because it should be randomized better. But anyway, so in terms of our acids, the HAs, strongest to weakest is HA1, HA2, HA3. Could you list the indicators from strongest to weakest? indicator 1, indicator 2, indicator 3. Which one is the strongest? Which one is the weakest? Now you're looking at the columns. Who is the strongest indicator? Red. Red is not an indicator. HIN1. Who's the second strongest? HIN2 and HIN3. Like I said, I need to redo this so it doesn't go 1, 2, 3, and you're just going to think it's 1, 2, 3. That's just because I did my data poorly, and I need to fix this for next time. Fix data.
How do we know
Okay, so this, remember, these point up to our indicator. HIN1 is facing the greater than, so it is stronger than NaOH. It is stronger than HA2, and it is stronger than HA3. Yeah? Whereas, and so we have, in our little data range here, we've got two things that HIN1 is stronger than. In our little range, we've got only one thing that HIN2 is stronger than, and over here we have 0 things that HIN3 is stronger than, right? Because there's no stronger thans in the HIN3. Well, there's this one, but I'm only looking at the HAs because the HCl and the NaOH are just for comparison. They're just to give us data. Okay, so we can make those comparisons. Would you be able to take those two lists, 1, 2, 3, 1, 2, 3, and either slot them together this way or this way from looking at the data? Give it a try. Okay. What we want is I want a list from strongest to weakest of all the acids, all the HAs and all the HINs.
So there's going to be 3 different lists.
So that no, it's going to be one list. So you have to decide, is it going to go HA, don't write this down. Is it going to go HA1, HA2, HA3, HIN1, HIN2, HIN3, or is it going to do something like this where we go HA1, HIN1, HA3, HA2. Remember, don't write these down because they're all wrong, okay, or they might be wrong. HA2, HA3, HIN2, HIN3. Like, how do they all fit together? Can you look at your data and figure that out? Give it a try. You're going to have to do direct comparisons between the HAs and the HINs.
How do we know the order of the HINs again?
How do we know the order of the HINs? These ones, 1, 2, 3. The HAs, because we had, when we went across this way, HA was stronger than the indicator, stronger than the indicator, stronger than the indicator. HA2 was only stronger than 2 of the indicators. And HA3 was only stronger than 1 of the indicators. Chat with your neighbor about this. See if you can figure it out. Who's going to be the top acid? Is it going to be, it's got to be either HA1 or HIN1, right? Which one goes on the tippy top? And then you can look at what goes at the very bottom. It's either got to be HA3 or HIN3, right? If it helps, you can put HA1, HIN1, right? That tells you HA1 is stronger than HIN1. HA2 is weaker than HIN1. So if you want to, you can fill that in and that might make it easier for you. HA3 is weaker than H. And I'm going to get rid of this because it's all wrong.
Both these are wrong.
Yeah, both of them are wrong. That's why I said don't write it down. I was just giving an example of how they would look together. Who is stronger, HA1 or HIN1? HA1. So HA1 is going to be at the tippy top, yes? Okay. HA1 is stronger than HIN1. And I've left a little room in between in case I need to write something in between. Yes? Now at the very, very bottom, maybe I'll give myself a little more room. Who is the weakest? Is it HIN3 or HA3? HIN3 is weaker than HA3. So HIN3 is going to go at the bottom.
So shouldn't HA be slightly higher? HA3.
HA3 is slightly higher, yes. So it's going to go there. Yeah? And now you can look and say, HIN1 has to go above HIN2. So HIN2 is going to be in here somewhere, yes? And now I need to figure out where HA2 goes. Yeah, is it going to go in here or is it going to go in here? Sorry, wrong arrow. Is it going to go here or here? The top one or the bottom one? Yeah, it's going to go where the top one is because it is weaker than HIN1. Okay. HA2 is weaker than HIN1, but it is stronger than HA1, HA2 is stronger than HIN2, so it has to go here. And now you have a list of all the acids from the strongest to the weakest. Yes? Okay. Now, if we wanted to make an acid-base table of this, and if you don't have anywhere to write this, please go get yourself an extra piece of paper because we're going to make our own little acid-base table just like the one in our data booklet. Okay, so go grab yourself a piece of paper.
The one that we usually work.
Yeah, the one with all the KAs on it, the KA table.
Why can't we just use that one?
Because we don't have HA1 and HIN1 on there. Oh, yeah. So I'm going to rewrite this because this is an ugly thing here. I'm going to try and tidy it up a little bit.
Or all these indicators. These indicators can change those, no?
Hmm?
And these indicators change.
Well, this is whatever indicators we have data for. Okay, based on this data, you could have different indicators with different data, and you would have to figure it out in a similar fashion. Okay? So there's our strongest acid to our weakest acid. If we look at our data table, does it just look like a list of acids? Is it just like that? Acids strongest to weakest, or is there more? There's more. We need to have the H plus and the base form on the other side. Does that make sense? If we want to make a table that looks like this? So what we're going to do is each of these are weak, so they're all going to have equilibrium arrows. And we're all going to have H pluses here. H plus, H plus, H plus, H plus, H plus, H plus. And over here, we're going to have the bases. Which base is going to be at the top? How would I label it? Similar to how I have labeled the acids. At the top, I have the strongest acids. At the bottom, I have the weakest acid. At the top, what kind of base am I going to have? Weakest base. And at the bottom, we're going to have the strongest base. And that's how you go through and analyze the data for a set of indicators and weak acids. And this is one of the reasons why this unit is harder than acid-base part 1, because it requires you to do a lot of like thinking through the data, and it's like a little puzzle, right? I think once you've done it a couple of times, it's not so hard. Fingers crossed. Okay. So we're actually not going to do any of this because we've already sort of done our own thing here, but this will allow you to do number 3 on page 20. Okay, so number 3 on page 20. And then you're also going to do number 8 on page 22. 3 on page 20 and number 8 on page 22. But we're going to learn something else before that because I will not be here tomorrow and I want you to have stuff to review tomorrow. So we're going to look at how to find a KB. And it is a small topic, so let's go and find it. So that is finding KB from the conjugate acid. This is on page 30. Not all weak bases are amines. Other common substances that act as weak bases are some of the anions. However, there are some anions that do not act as weak bases. These are the ones that do not act as weak bases. What do you know about all of these? What's special about these guys? What do they all have in common?
They have a negative charge.
They have a negative charge, but so do all anions. But these anions in particular do not act as bases. Does that list look familiar at all?
Like, if we go over it, like that.
Well, I'm just thinking, like, if you say I, Br, Cl, NO3, HSO4, do all of those have something in common?
They are weak bases.
No, they're not weak bases because they do not act as weak bases. They are conjugate bases of strong acids. Okay? They are all conjugate bases of strong acids. So if you look at that list is right there on your table. Yeah, right at the very top, and all the arrows go that way. So why can they not act as weak bases? It's because their conjugate acid is too strong, and it will not, it means these guys are too weak to act as acids. Too weak to act as bases, sorry. These anions are all the conjugate bases of strong acids. So other than the two strong bases, who are the two strong Bronsted-Lowry bases? Who are the two strong Bronsted-Lowry bases?
O2 and 8.
O, not O2, O2 minus. And
Wait. Oh, yeah.
who's the other one? Who's the other one? NH2 minus, okay? Other than that, other than those two, and the conjugate bases of the strong acids, so any bases that are in either of the gray sections, all the rest of the anions are weak bases. In other words, the ones in the white section. This shouldn't be too surprising because when we were looking at acids, where were all our weak acids? Our weak acids were all the ones in here. These were all our weak acids. Yes? That means who are all the weak bases? All of these guys are the weak bases. So anything that's not in the gray zone, if it's on the left-hand side, it's a weak acid. If it's on the right-hand side, it's a weak base. So you can see there's tons and tons of negative ions, negative, 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 that are all weak bases. So far, so good? I don't care whether you're saying yes or no. I'm just going to move on because you guys aren't saying yes or no anyway. Speak up if you need me to stop anywhere. You will not be given the Kb for these anions. You might be, but it seems unlikely because you can calculate it. To find the Kb, this is a new formula. Kb is equal to Kw over Ka of the conjugate acid. And because that is really, really long to write, you might just say Kb is equal to Kw over Ka of the conjugate acid. It has to be the conjugate. So Kw is equal to Ka times Kb, where these two, the acid and the base, are conjugates. So we used to have Kw is equal to H times OH, that still applies, but Kw is also equal to Ka times Kb of the conjugate acid. And because we are pressed for time today, I'm not going to go through where this formula came from. Feel free to read it on your own if you want to. Let's use this formula to calculate Kb for F minus. F minus can act as a base. We get HF plus OH minus. Therefore, oh look, this is a weak acid. So that can happen. Yay! F minus is able to act as a base. So the Kb then of F minus, the value of it is going to equal Kw over Ka of what species? HF, the conjugate acid. So that's going to be 1.0 times 10 to the negative 14 divided by 3.5 times 10 to the negative 4. That's just, yeah, it's on the table. Okay? And we do that. And we get 1 times 10 to the negative 14 divided by 3.5 times 10 to the negative 4 is 2.857 times 10 to the negative 11. So that's going to be 2.9 times 10 to the negative 11. If that's all you're asked for, you will stop there. But if you're asked to use the Kb, don't put your book away. We're not done. We still have another 4 minutes. Why are we packing up? That would be your final answer. If you are going on to do something else, you will use that entire number in your calculator, right, rather than rounding it off. Yeah, if you're going to use it for something else. All right. It is a bit of a pain in the butt to always be writing out the Kb of A minus equals Ka of the conjugate acid HA, but rather than just writing this, however, it's going to prevent you from making a very common mistake. And this is the common mistake. Find the Kb of HCO3. Here is how to do it wrong. Kb equals Kw over Ka. That looks good so far, yes? That Ka value, though, is the Ka for HCO3 minus. Is HCO3 minus the conjugate acid of HCO3 minus? Is HCO3 minus the conjugate acid of HCO3 minus? No, this is not the conjugate acid. No? Okay. (5.6 times 10 to the 11 is the Ka of HCO3 minus, not the conjugate acid. Who should we use? We should use, no, we want the conjugate acid of HCO3 minus. We should use, yeah, Ka of H2CO3, which is the conjugate acid. So what we're going to do here is we are going to have H2CO3. There's its Ka. So Kb of HCO3 minus is equal to Kw over the Ka of H2CO3. You need to make sure that these two species are not the same. Okay, this has to be, this is our conjugate acid. And that's going to be 1.0 times 10 to the negative 14 divided by 4.3 times 10 to the negative 7. And we get 2.3 times 10 to the negative 8. Can you calculate a Kb for Br minus? Br minus. Can Br minus act as a base? What would we get?
Nothing.
We would get HBr. Can we make HBr? No, because this is strong. So there is no Kb for Br minus. We're going to have a quiz on sections 5.1 and 5.2 on Friday. Quiz on indicators and Kb on Friday. I will put all the homework up on Teams, okay? And tomorrow is going to be a work period because I'm not here. I'm going to my son's convocation. So his graduation ceremony at UBC. Yeah, so engineering. So he's done now, finally, only 6 years later. He did co-op, and he also did not take like 6 credits per, like 6 courses per semester, because that's crazy. So it took him longer than 4 years to finish.
This make me more instantly.
Everything. I'm just gonna give them some work to work on. Yeah, so some of them won't have done any of the work from the last 2 days, because that's how we roll apparently. Yeah.
Man, I can't be saying anything. I never did any of the work either.
Well, I'm honest about now.
I am honest, bro. There's no point of lying. She
No, I know, I knew.